Hello everybody, this is the third video in the series Mode Shapes. In the previous video, we discussed about altering the boundary conditions and check what effect it has on the natural frequencies and mode shapes of a square plate. In this video, we're going to alter the structural properties and again study the effect it has on the natural frequencies and mode shapes. So this is the same old plate that we're using for this analysis. The only difference is we're altering the material. We're using plastic instead of steel. So all the dimensions are still the same, 100 by 100 by 2 mm thick. The only difference is we're using ABS plastic instead of steel, and the plate is still constrained along the perimeter and in all 6 degrees of freedom. So the plate is constrained along the edges as, similar to the last video. And these parameters still remain the same because all we did was alter the material. We didn't change the boundary conditions, so which means the number of constrained nodes are still the same, and the total degrees of freedom of plate is still 486, which means that's the matrix that needs to be solved in order to accomplish this. So once we perform the computation, we obtain the results. So these are the natural frequencies of the plastic plate, that is the 100 by 100 by 2 mm thick plastic plate. I've chosen the first 8 modes, so these are the values. Now these are the natural frequencies. Now let's take a look at the mode shapes. So this is the first mode of the plastic plate at 493 Hz. This is the second mode at 1005 Hz. Third mode, again at 1005 Hz. Fourth mode at 1435 Hz. Fifth mode at 1819 Hz. Sixth mode at 1831 Hz. Seventh mode at 2169 Hz. And finally, 8th mode at 2169 Hz. Alright, so now let's compare the frequencies between, the steel plate and the plastic plate. Now, clearly, as the theory states, we have altered the structural property, meaning we have changed the material, and we should expect a change in the natural frequency, which is clearly evident here. As you can observe, the natural frequencies have changed. But in addition, what about the mode shapes? Well, the mode shapes can change or cannot change, because we're altering the structural property. If we alter the boundary conditions, we're very much certain that the mode shapes will change, but let's have a look at it anyway. So this is the mode shape comparison. On the left side, you see the mode shape of a steel plate. On the right side, you see the mode shape of a plastic plate. So this is the first mode, and I can observe that the mode shape is the same, except that the amplitude is a little different for the plastic plate. So this is the second mode shapes. Well, in this case, they are different. This is a third mode shape. Again, they're different in this case. This is the fourth mode shape. Well, they're same. Again, the amplitude is different. This is a fifth mode shape. Similar, amplitude is different. This is the sixth mode shape. Again, same but different amplitudes. This is the seventh mode shape. Different. And finally, the eighth mode shape. So to conclude, what we did was we only altered the material properties. Okay, we just changed the material from steel to plastic, ABS plastic to be specific, and nothing else was changed. The boundary condition was still the same. The shape and thickness of the plate were all the same. So as a consequence, the natural frequencies, have to be changed anyway. They were different, but the mode shapes were same in some cases and different in other cases. Alright, thank you for watching this video. I hope you enjoyed it. Have a great day.